Friends, let's learn polarization of dielectric molecule. When dielectric molecules are kept in an electric field, then intrinsic dipole moment is produced inside the dielectric molecule for both polar and for non-polar dielectric molecules. This phenomenon is said to be polarization of dielectric molecules. Let us see this one by one. Number A, polarization of polar dielectric molecules. Let us have here polar dielectric molecules. Polar dielectric molecules have plus and minus charges. So here we have plus charge, here we have minus charge, here plus, here minus, here plus, here minus, minus charge, here plus, here minus charge. So this is polar dielectric molecules and there is no electric field. This means that electric field E is equals to 0, no electric field. So we have minus to plus is P1. This is intrinsic dipole moment for this molecule. In the same way for this molecule we have P2 and so on, so on. So we have P is equals to P1 plus P2 plus P3 plus P4, which is equals to 0, because this here we have P3, here we have P4, and we know that direction is from minus to plus side, minus to plus. All have direction from minus to plus, direction from minus to plus. So this direction will cancel out because they have same magnitude. When this is kept in a presence of electric field, this means that electric field is not 0. We have plus plates here and we have minus plates here. Then what will happen? These dielectric molecules start rotating, and after rotating they align themselves like this in a line. They align in a line. So we have a minus charge here, plus charge here, minus plus, minus plus, minus plus. We know its dipole moment is P1, direction plus to minus. It have P2 plus to minus to plus. It have P3 minus to plus. It have P4 minus to plus. So all have the same direction. So you have P is equals to P1 plus P2 plus P3 plus P4. This intrinsic dipole moment not equal to 0. So when you have polar dielectric molecules, in the absence of electric field, their sum of intrinsic dipole moment is 0. But in the presence of electric field, their sum of intrinsic dipole moment is not 0. This phenomenon is said to be polarization of polar dipole molecules. So if one asks from you that what is polarization of polar dipole molecule, then the answer is, in the absence of electric field, intrinsic dipole moment are 0, but in the presence of electric field, intrinsic dipole moment is not 0. This is said to be polarization of polar dielectric molecule. Now let us understand polarization of non-polar dielectric molecule. Polarization of non-polar dielectric molecule. When you take non-polar dielectric molecule, then non-polar dielectric molecules have center of plus and minus charge coincide. So plus minus center is here, plus minus center is here, plus minus center is here, plus minus center here. So here you have electric field E equal to 0. So P1 is equals to 0, P2 equal to 0, P3 equal to 0, P4 equal to 0, because they have no intrinsic dipole moment. So their sum is also 0. So you have P equals to P1 plus P2 plus P3 plus P4, which is also equal to 0, because P1, P2, P3, P4 does not exist. But what happened when you place electric field? So it is polarization of non-polar dipole molecules. What happened? This plus and minus charge start stretching. They stretching. So after stretching, this minus sign will move towards plus, and this plus will go away from this plus, and this move towards negative side. So after stretching, they align in a line, and again, so net dipole moment will be produced. So we say that polarization of non-polar dielectric molecule is the phenomenon in which there is no intrinsic dipole moment in the absence of electric field, but in the presence of electric field there is net dipole moment. So in both the cases, what you have seen? You have seen that dipole moment created when polar or non-polar dielectric molecules are kept in external electric field. Now you are going to understand what is polarization or polarization per unit volume. It is next is polarization or polarization per unit volume. Capital P is equals to small p upon V is said to be polarization per unit volume. So here P is dipole moment. So net dipole moment per unit volume is said to be polarization or polarization per unit volume. This is said to be net dipole moment. What is this? This is net dipole moment divided by volume of substance. This means that if here we have a substance and here we have plus charge plates, here minus charge on this plate, and this is the dipole moments are arranged like this. Here they are arranged like this. So here minus plus, minus plus, minus plus, minus plus, minus plus, minus plus. So this have P1, this have P2, this have P3, this have P4, P5, P6, all are vector, okay? All are vector from minus to plus side. So what is P? P is equals to P1, P2, P3, P4, P5, P6. This is said to be net dipole moment, and it's have area of plate is A, and here length of this is equals to L. So you have volume V equals to A into L length. So P divided by V is said to be polarization per unit volume, or it is single word, it is said to be polarization. SI unit of polarization is, you know that what is P? P stands for here, P equals to Q into 2A. P equals to Q into 2A. Q stands for charge and A stands for distance. So SI unit of P dipole moment is coulomb meter, and SI unit of volume is meter cube. So you have coulomb per meter cube. So SI unit is coulomb per meter cube. Now you are going to see one important topic which is known as susceptibility or electrical susceptibility. You are going to see electrical susceptibility. Here this is P. P stands for polarization. Polarization directly depends upon electric field. This means that as polarization P or polarization per unit volume directly depends upon electric field. If you increase the electric field, polarization will be increases. If you decrease the electric field, polarization will be decreases. So this, when you remove this proportionality sign, you have to give a constant. This constant is said to be chi e, where chi e is electrical susceptibility susceptibility. This is electrical susceptibility. Electrical susceptibility is a constant of proportionality here. Now you are going to understand the SI unit for electrical susceptibility. So what you have? You have P, polarization, is equals to electrical susceptibility into electric field. SI unit of SI unit of polarization is coulomb per meter square, and SI unit of electric field E equals to AF upon Q. So SI unit is Newton for force, and for coulomb it is charge. For charge it is coulomb. So you have electrical susceptibility is equals to coulomb square per Newton per meter square. SI unit of it is electrical susceptibility. Thus you have learned what is polarization of dielectric molecule. When dielectric molecules are kept in an external electric field, then intrinsic dipole moment is created for both polar and for non-polar dielectric molecule. This phenomenon is said to be polarization of dielectric molecule. Do like, share and subscribe my channel.